have Elijah Creedon, who's going to talk about characterizing changes in some Adirondack lakes. He's a good friend of my son's, actually, and lives near him out in Colorado, so it's kind of cool to introduce you. So take it away.
Thank you very much. Similar to the previous talk, I'm also a lake management student at SUNY NYCAFS. So some of this background is going to look pretty familiar, but if you were paying attention the first time, you'll catch it now. So, like I just said, I'm a student, and we get to select from a list of lakes and kind of pick one that's more tailored to the things that we want to look at, and work with that lake association in answering their main concerns, what goals they want to see out of their water body, and really just hone in on what they can do to make their lake how they want to see it in the future. So I am working on Deer River Flow at Horseshoe Pond. So this laser works here. Yeah, look at that. So that's Deer River Flow. That's Horseshoe Pond up there. They're connected. Horseshoe Pond is actually has an outflow that goes into Deer River, and which flows out into the St. Regis and on into the St. Lawrence. See, it's way up there, up by Malone. It is within the Adirondack Park, but just barely. And, Deer River Flow is about 360 acres. Horseshoe Pond is about 60. And surprisingly, they have about the same max and mean depths, with a mean of 1.5 meters and max of 3. I'd also like to talk about the watershed of the area. I went ahead on this table here and I actually removed all the values that were less than square kilometer. So we're left here with the main forest types in the watershed. You can see it really is majority forest. It's pretty refreshing to see some watershed characteristics like that. Not too many watersheds can put up numbers like that in New York State. So very nice. So getting into the past management, which is really going to affect what we do and affect what needs to be done in this lake. It was originally dammed in 1830. It was kind of a flowed section of meadow, like you see a lot in the Adirondack Park. And it was actually dammed to run the furnace for iron mining out there, which ended, and the dam was then actually built up after the iron mining ceased, which brought it to the lake levels we see now about 1904. It then switched ownership in the late 80s, was privately owned, and then DEC actually purchased that land. And so from that, we see a lot more personal recreation from the public on that water body than we would have historically. Also about that time, 1986, DEC did a gillnet survey out there, which I'll get into more in a little bit. Moving on, in the early 2000s, we saw CSLAP, or the Citizen Statewide Lake Assessment Program, begin in both lake basins, which we'll use for historical comparisons to the more up-to-date water quality readings. Also in that time, we saw Eurasian water milfoil become present in both lake basins, which really is the main concern of our lake stakeholders moving on in the future. So what is the main goal of Horseshoe Pond Deer River Flow Association, the longest lake association? So they really want to see Deer River Flow and Horseshoe Pond be maintained as an intact and beautiful Adirondack Lake community. They want to see things look just as they should be, and the last thing that they want to see is low fish and catch rates. You know, they don't want their lakes to be choked up with weeds. They want to maintain a native, healthy plant diversity, all those good things. So to look into that, what I did is I focused on water quality, the fishery, the plankton, and the aquatic plants within both lake basins. And today, I'm really just going to be focusing on the water quality and the fishery in this presentation. Moving into the water quality methods, I mirrored CSLAP with my methods so that that data would be pretty comparable. So you see the highlighted in gray there values were all collected at half-meter intervals with a camera, and then they were then analyzed back in the lab. The non-highlighted values there were collected with the YSI, and they were both sampled over those red stars there in each basin, which is the same location that they sampled for CSLAP. In those comparisons, CSLAP often just does surface samples, mostly because that's what the lake associations can afford. So even though I sampled at half-meter intervals, and that data will be presented to the stakeholders, a lot of these comparisons are those surface readings, so they're more directly comparable to what CSLAP had. Also collected chlorophyll A readings, and we got a SECI depth at each sampling instance. So going right into our results here, we've got a temperature isopleth from Deer River flow, and you can see there's really no stratification. We got some building up in the winter there briefly in February and a little bit again in October. It's these brief periods of stratification, which are indicative of having a 360-acre lake with a mean depth of not even 2 meters. There's a lot of mixing going on and high outflow as well. So our dissolved oxygen, following that trend of a lot of mixing, it's pretty sweet that we get to see a lake basin that's that large and that shallow have good oxygen. It really is nice and helps support a good fish community, which you'll see here in a little bit. However, we do see a little bit of concern in our pH values. They're healthy through most of the season, but there are those spikes there in February and March, which are really linked to our pretty low alkalinity concentrations. Moving on to Horseshoe Pond, we see some better stratification set up on the winter, and again there coming into the summer. A little weak stratification, but we also had some pretty big storms this summer that kind of broke that stratification up a little bit. You do see some stronger stratification trends in dissolved oxygen, and we see there in the winter quite a bit of anoxia buildup under the ice. And as most of you know, last winter wasn't even all that snowy. But on that topic of anoxia, Horseshoe Pond does have a pretty sizable inlet and outlet. So it is feasible that those fish would have some refuge from that anoxia in there. You do see another spike right here in the middle of the summer. And then we actually see it leave again in August, when you'd still expect it to be stratified and still building. And this trend, I believe, was linked to a Eurasian water milfoil treatment that they did back in May. And I think that was just seeing that Eurasian water milfoil dying off and being consumed by bacteria. Once again, we have really similar pH trends to Deer River flow, and also, again, linked to our alkalinity. Something I'll mention here too, you see these blank months. Those are times when the ice conditions weren't safe to sample. Some other ones you see some blank years as well. The Lake Association, they wanted to be kind of frugal with their funding of CSLAP, so they'd go back and forth. They'd sample Horseshoe Pond for a couple of years, they'd sample Deer River flow for a couple of years. So that's what those gaps are there. So getting into our second depth, you see it's pretty low. We're looking at about 1.5 meters, pretty much year-round. You did see it clear up a little bit in the winter. And that trend is pretty consistent over the whole time, basically. I'll get into it in a little bit, but there is a significant negative relationship with SECI depth in both basins over time. And chlorophyll A, once again, we have some pretty low readings there. Actually, let's step back to our SECI depth for a little bit. The lake is very tannic, like what you'd see in a lot of Adirondack water bodies. It really limits that light penetration, and that's why that SECI depth is so low. And that's why with such a low SECI depth, we see low chlorophyll A scores still. Because it's not that there's a bunch of nutrients boosting or negating the water clarity, it's just that there's light penetration inhibition from that tannin concentration in dissolved organic carbon. So, trophic status index, this is a little formula that NOM's developed to look at the age or trophic status of a lake. You take your 3 main values that drive your trophic status, throw it in a little formula, and there you go. You can see it's pretty all over the place, which is interesting. You can see again that that SECI depth looks super eutrophic, and you'd expect that chlorophyll A would follow that as well, but it doesn't, because of those tannins in the water. neat way of almost self-regulating the water body from being too productive. So some long-term trends, like I said, we got some p-values out of things, so it was good. So I ran general linear models on pretty much all of those water quality parameters that were recorded by CSLAP and myself. What's reported here are the only values that had a significant relationship, and they were all negative. I think that really is linked to DEC taking ownership of that piece of land. It stayed wild for pretty much the entire watershed, which really allows us to see that there are really no concerning changes with water quality. It's pretty surprising, things that have maintained. There's not even a significant relationship with temperature over time since the 2000s in either basin, which is cool to see. Moving on to our fishery, I conducted a boat electrofishing survey of Deer River flow, also collected some otoliths from Horseshoe Pond, close 100 times. And like I said earlier, the historic gillnet survey in '86. This gillnet survey, they did 10 nets were set out, 150-foot experimental gillnets, and they were set overnight for about 21 hours. They recorded their data a little interesting. They got a total weight of each species and a number of individuals, and then they got a maximum and minimum weight. So you see my comparison from the surveys, it looks a little odd, that's why. So this is from that electrofishing survey. You can see here we got some pretty healthy and diverse fish community. Just going to limit it kind of quickly, about 5 minutes. Most important probably on here, I think, is we got trophy-sized white sucker, which is pretty cool. And our relative weights also in pretty good shape. We do see that northern pike are still healthy, but the lowest on there. You'll note that largemouth bass are the opposite of that, they're the highest, which I'll talk about when I compare that gillnet survey. Those otoliths I pulled, these are the results of those 5 fish right here. And this black line is actually a standard, almost it's an average length and age of each age. That's for regions 5 and 6. So you can see they're growing well, they're just growing less. And back to that comparison. So what I did is I got the mean weight of individual fish of each species, and everything went up with the exception of northern pike. One thing you'll note about that and on this graph is there's no largemouth bass, because there weren't largemouth bass during that gillnet survey, which I think it's fair to say that that has a lot to do with why we're seeing that decrease in mean weight as well as the lowest relative weight of that species. So in summary, you see a lake with a watershed that allows it to be pretty consistent and pretty healthy. There are some concerns of anoxia in Horseshoe Pond, but as of now, it hasn't became a serious limiting factor yet. And as far as the fish community goes, you see a pretty diverse and abundant fish community. Pretty good length frequency histograms. We got good size and age ranges of a lot of fish. And we do see a little concern with the northern pike, but overall, even so, they're still in pretty good shape. With that, I'd like to thank SUNY Oneonta, biology department there, the Biological Field Station, Scriven Foundation, Ms. Fola, as well as SUNY Goldsville. So really appreciate everyone's help, a lot that went into this. And taking questions.